Today we're going to look at how we can solve quadratics by factoring. Actually, in this video we won't be solving quadratic equations quite yet. We're just going to investigate some of the basics of factoring. The way I like to introduce what factoring is by actually doing something we've already become pretty comfortable with by now, which is multiplying two binomials together, such as 2x minus 1 and x plus 3. These are binomials because they have two terms, right? Each two terms there and another two terms there. So if we were to FOIL these, just as a quick review, we would multiply the first terms together, 2x times x to get 2x squared, and then we can do 2x times positive 3 to get 6x, and then multiply negative 1 and x to get minus x, and then negative 1 times positive 3 is minus 3. If we combine the like terms, our final product is 2x squared plus 5x minus 3. So what we've done is multiplied the product of two binomials to get a trinomial, which is just our quadratic in standard form. Taking your trinomial and trying to figure out what the product of the two binomials is the process of factoring. Factoring sounds like a scary word, but basically all it is multiplying. It's a fancy way of saying we're multiplying. So factoring simply rewrites an expression as a product, which, remember, the word product just means you're multiplying. So the first and most basic thing that we need to understand when we are factoring is just what are factors and how do we factor out, let's say, the greatest common factor of a pair of terms or even more. So we're going to do a few examples together, and what I plan on doing is the first three examples, A, B, and C, I'm going to be painfully detailed and really kind of go slowly to make sure we're all on the same page with this. And then when I do D, E, and F, I might just do it a little bit faster so that we don't have to spend so much time. Hopefully you'll feel pretty comfortable with that. So if I'm looking at factoring out the greatest common factor of, let's say, an A, 2x and plus 4, I want to first list all the factors of the terms. 2x just means I'm multiplying a 2 and an x. I can't break 2 down anymore because it's a prime number. However, 4 can be broken down into the product of 2 times 2. Now, the only factors that these two terms have in common is this 2. So I can only factor out the 2. Now, if I factor out the 2, basically what that means is I'm dividing each term by 2. If you divide 2x, and I'll just write over here, if I divide 2x by 2, these cancel and I'm left with an x. And if I divide this term, 2 times 2, by the factor of 2, I'm left with the other term, or the other factor, 2. So if you factor out the GCF of a 2, you're left with an x and a 2. Now, what you should get in the habit of doing is once you factor out the GCF, it's really easy to check by distributing. Now, you may not actually write this out. You might even just do it in your head when you get good at it, but just for this problem, let's do it. If I do 2 times x, I would get 2x. If I do 2 times the positive 2, I'd get 4, or positive 4, which is my original answer again. So I know I factored it correctly. And notice how I went from the sum of two terms to the product of 2 and x plus 2. Now I've changed it into a multiplication problem. Let's look at B. In B, I can break down 3x squared into the product of 3 times x times x. 5x, I can just write as 5 times x. The only thing these guys have in common is an x. So I can only pull an x out in front, and what's left behind in this term is a 3x, so I'm going to write that here, plus I'm left with that 5, so I have a 3x plus 5. If I distribute the x times 3x would be 3x squared, and then x times positive 5 is positive 5x. That matches the original expression. I know I factored it correctly. Let's look at, let's look at this next example. 12x squared plus 8x cubed. 12, I know I can break down into the product of 4 times 3, and then x squared is x times x. 4 is really 2 times 2 times a 3. And then I have an x and an x. So I've broken down 12x squared as far down as I could. 8x cubed, let me write the plus side down. 8 I know is the product of 2 times 2 times 2. There's 3 factors of 2. And I have an x cubed, so I have an x times an x times an x. There's 3 factors of an x there. Now, notice how I have a pair of 2's I can factor out of each. And I also have a pair of x's that are common to both terms. That means I can pull out a pair of 2's, in other words, a 4, right? 2 times 2 is really a 4. And I can also pull out these x's from each. So I can pull out a 4x squared. That is my GCF. That leaves behind that 3, and that leaves behind a 2 and an x. So I'm going to write as 3 plus 2x. Now that was a little bit trickier. I definitely want to check this by distributing. If I do 4x squared times 3, that's 12x squared. And if I do 4x squared times 2x, that's a positive 8. And then x squared times x is x cubed. Is that my original? Absolutely. So I know I factored this one correctly. Now let's go on and do a couple more, but I'm going to move a little bit quicker here. When I look at negative 5x and a 24, 5 does not go into 24, and 24 doesn't have an x term. There is no GCF, so this is not factorable. Not factorable. Still having a hard time writing with the stylus. Let's look at E. Now I have 3 terms, so I have to compare all 3 terms and look for a GCF. Now, I do have a 4 here, and I think 4 goes into 16, and it goes into 20, and I have x's in the first 2 terms, but not in the last one. So x is not a common factor to all of them, but however, 4 is. And usually, guys, when your first term has a negative sign in front of it, you want to pull out a negative more often than not. So what I'm going to do is I'm going to pull out a negative 4 from each term. Now, basically, what that means is I have to divide each of these terms by negative 4. If I divide negative 20 by negative 4, I get a positive 5, and I'm still stuck with that x squared. If I divide a negative 16x by a negative 4, that's going to be a positive 4 with an x. Negative 4 divided by negative 4 is positive 1. So this is the factorization of the above. Now, I would maybe double check by distributing the negative 4. If I do, I get negative 20x squareds. Negative 4 times positive 4x is negative 16x, and negative 4 times 1 is negative 4, and that does match the original, so I factored correctly. If we look at this guy, I have a 15, a 25, a 1. Geez, all I can pull out is maybe a negative 1 because there's a negative in front, so let's do it. If I pull out a negative 1, I'm just going to be left with a 15x cubed. If I divide 25x squared by negative 1, I'm left with a negative 25x squared. I probably shouldn't have written the parentheses so close here. Let me see if I can rewrite this. I'm left with 25x squared. And then negative 1 divided by negative 1 is positive 1. So this is my factorization. If I distribute the negative 1, you do get the original negative 15x squared plus 25x squared. Oops, that was an x cubed there, sorry. And then a minus 1, which is the original. Let's go on to the next slide, where we're going to actually apply this now by factoring by grouping. So when we factor by grouping, we usually use this if we have 4 terms. Okay, so in the examples you're going to see today and tomorrow in class, I'm going to actually give you 1, 2, 3, 4 terms. Okay, that's an indication that you're going to factor by grouping. Now, I know you might be looking at this expression and saying, well, can't I just combine these? They're like terms and write that as negative x plus 3x. Isn't that just 2x? Yes, you are totally correct. You could add those together, but please don't, just for today's sake, because we're going to try to use this to help us factor other quadratics where you're not going to want to do that. So just let's pretend that we don't know how to add those middle terms together and combine them. And just let's play the game and learn how to factor by grouping. When you factor by grouping, what I want you to do is pair up the first couple terms and pair up the last couple terms. And what we're going to do is try to pull out the GCF of the first pair and the GCF of the second pair separately. Now, if you look at the first pair, I have an x squared minus an x. Both of these terms have the factor x, and x is the greatest common factor of both. If I pull out that greatest common factor, x, I'm going to be left with an x minus 1. And again, if I distribute that, x times x is x squared, x times negative 1 is negative x. So that's the first part. I'm going to copy down the plus sign. Now I'm going to do the same thing for the second pair. I have a 3x minus 3. The GCF for a 3x and a negative 3 is just a 3. If I divide each of those terms by 3, 3x divided by 3 leaves an x, and a negative 3 divided by 3 leaves a negative 1. Now check this out. I've just changed 4 terms into really this term plus this term. Now you'll notice both of these terms have an x minus 1 in them. Those are common factors. What I'm going to do is I'm going to factor out that GCF of an x minus 1. If I factor that out, I'm left with an x, which I'm going to write inside of my first parentheses, and I'm left with a positive 3. And I've just factored this original expression into the product of these two binomials. Now, we're not going to do this all the time, but let's just check that we've done this right. If I have x minus 1 times x plus 3, we could FOIL to check. X times x, x squared. X times positive 3 is positive 3x. Negative 1 times x is negative x. And then negative 1 times positive 3 is minus 3. I think you'll note that that and the original term are the same, with just this and this guy being reversed. So it's really the same as x squared minus x plus 3x minus 3. It's actually equivalent. We've just written it as a product. Let's take another look. If I pair up the first two and I pair up the last two, the first two have a 3 and an x in common. If I divide a 3x squared by 3x, that leaves just an x. And if I divide 6x by 3x, I'm left with the factor of 2. Again, if I distribute, that would be 3x squared plus 6x. Out of the second pair, I can pull out a positive 2. That's the GCF. 2x divided by 2 would leave an x. 4 divided by 2 would leave a 2. Now check it out. I have x plus 2 and an x plus 2. Those are common factors. I'm going to pull out that common factor of x plus 2 from both terms, and that leaves the 3x plus 2 for my other factor. And if you wanted, you could FOIL that out, and you will get back to the original. I want to look at two more, if I can, quickly. We're going to look at two more, but these are a little bit more interesting because there's some negatives involved. 4 terms, I'm going to pair up the first two. Pair up the first two and the last two. And out of the first two, 8 and 20 both have the greatest common factor of a 4. And an x squared and x, I can pull out 1x. If I divide 8x squared by 4x, I'm going to be left with a 2 and an x. Negative 20 divided by 4 is negative 5. And x divided by x is canceled, and I'm just left with that. If I distribute 4x times 2x, I do get 8x squared. 4x times negative 5, negative 20x. Now, because I have a negative here, I'm going to factor out a negative, and the greatest common factor of 6 and 15 is a 3, so I think I can pull out a negative 3. If I do, negative 6x divided by negative 3 would be a positive 2x, and a 15 divided by negative 3 is going to be a minus 5. Again, if you distribute negative 3 times 2x, you'll get negative 6x, and negative 3 times negative 5 is positive 15. Notice how these two terms are the same. I can pull that out the 2x minus 5, and that leaves me with a 4x minus a 3. And we are in good shape. Let's do one last one. I have the first pair and the last pair. The GCF of a 9x squared and a negative 6x would be a 3x. If I divide 9x squared by 3x, I think I get 3x. Negative 6x divided by 3x is negative 2. Again, if you distribute, you will get 9x squared and a minus 6x back. Now notice how this is a negative here. I'm going to pull out a negative. Let's see, what's the GCF of 12x and 8? I think just 4 goes into both of those. If I pull out a negative 4 from the negative 12x, that's going to leave me with a positive 3x, and 8 divided by negative 4 is negative 2. You want these binomials to match, and once again they do. The 3x minus 2 is common to both, so I can pull that factor out, and I'm left with 3x minus 4, and we're all set. I hope you guys have a good idea of how to get started with factoring by grouping. Thanks for watching.